Hey, hi. What I'm gonna do today is continue on where we left off last time in talking about how to do option pricing. You know, this is the binomial option pricing model. I will give you a very simple but extraordinarily powerful model which help you to understand the option pricing models framework and even to drive the theoretical pricing formula. This will be for various kinds of option, include exotic style and vanilla style, something like that. Uh, this is, although this is a very simpler version of Black-Scholes formula, but if you understand this formula, this model, you can generalize natural way to be Black-Scholes formula exactly. Okay. The model, by the way, is called the binomial option pricing model, which has been derived originally by Cox, Ross, and Rubinstein when it was 1976 when they were working for UC Berkeley. This is very simple, but this is much more commonly used than the black shows in the Wall Street. This is why is it more commonly used than black shores, even though it is a simpler version of black shores. Do you know why? Because it is a very simple, so simple that with basic high school algebra, you can work out all the analytics required in this pricing model, even even to drive a pricing model. This is the reason I love this model for almost all kinds of option option products. Okay, so let me explain in more detail about how it works for a especially call option vanilla style. Okay, so we have very simple economy. Uh, we have got stock XYZ. Okay, but we want to do option pricing of especially call option on that stock with the stock price K and maturity date very simply tomorrow. Today and tomorrow. Just one day is options maturity, remaining time to maturity. Okay, so current price is current stock price is S0, and tomorrow stock price will be S1. We assume. Uh, if I ask you what is the payoff of call option, especially vanilla style, tomorrow at maturity date, uh, can you can you answer these questions? Do you know that? Okay, the vanilla call options payoff is like a maximum of tomorrow's stock price minus strike price over zero, bigger of those two. This is the call options payoff, what's called, that is to say, this is the value of call option at maturity date. Okay, so tomorrow at tomorrow stock price is one, and tomorrow's call options value is maximum s minus k, comma 0, bigger of those two, what I want to do, the problem we want to tackle is that what is current call options price? How can you do that? Let me explain in more detail, okay? Before we hand, as I mentioned last lecture, we have to say something about dynamics of stock price. That is to say, we have to specify how stock price behave from today till tomorrow. Okay. So as you know well, Black-Scholes assume that the stock price follow continuous Brownian motion. This is the continuous version of random walk, as you know well. They are under the assumption of geometric Brownian motion in continuous version, which is a very, very complicated mathematical term. They derived the complicated partial differential equations, which Black-Scholes PD satisfy. So this is very, very difficult to understand and work out analytics, but we don't have any complicated mathematics, so we will not follow this approach. We just demand you very simple mathematics. I know, as I know, you have enough mathematics that it may take to implement this binomial option pricing. Okay. What is our assumed stock price dynamics? What I want to say about how stock price behavior from today till tomorrow is a coin flip. Bernoulli trial. This is the technical term. Let me explain about this. Okay, the stock price either goes up or goes down. Okay, when it goes up by amount of D, which means tomorrow's stock price will be S0, today's stock price multiplied by U, gross amount. Or when it goes down by factor of D, which means tomorrow's stock price is S0, today's price multiplied by D. Okay, for example, some stocks goes up when some stocks goes up by 10%. It means that you have to be 1.1. Okay. In some case, when some stocks goes down by 10%, it means that D have to be 0.9. Okay, this is what we assume that stock price statistical behavior. Okay, and in addition, when stock price goes up with a probability P and goes down with stock probability 1 minus P. But probability P and 1 minus P need not to be 50-50. It does not have to be. We just assume the probability is equal to some for example, point 0.3, point 0.9 is something like that. Okay, this is a simple framework, one period binomial option pricing model. Okay, do you agree that we have just the two possibility that the stock price can take on? Do you agree that? Is it enough, pretty well, to be generalized? Okay, let me explain in more detail about generality of this setting. Okay, if you have, suppose you have a growth stock which is doing quite well nowadays. When he goes up, it goes up by 10%, huge amount of return rate. And in other ways, when it goes down by 1%. Okay, less than growth rate. So when it goes, when you have this kind of stock, you can come up with the stock having a positive trend, which means positive return rate in average. Actually, when you doing average of these stocks with respect to probability, it depends on depending on what they are, it has positive return rate. Okay. On the other hand, if you have some stocks which is decline in value, it goes down by factor of D, which means D is obviously much smaller than U. Okay? If you average out, you have the stock will be a negative trend. Okay? This is a very, very pretty general setting. Okay? Let me see. If you agree, it's true that stock can take only to value. How about options value? You know, how about option value? Can you answer about these questions? Okay. If stock price can take only to value, option value can only to value also, because you know tomorrow's options value will going to be what? Can you answer me? Okay. Remember, the stock price, the call options payout tomorrow is equal to what? A maximum as 0 multiplied by U. This means tomorrow's stock price minus K, comma 0, bigger those of 2 in upstate of stock price tomorrow. And when stock price goes down in downstate of stock price, what about call options value tomorrow? Okay, exactly. Tomorrow's option value at downstate is equal to maximum D times S0 minus K, comma 0, that is to say, bigger of those two. Okay? What I want to say about stock price dynamics and call options, two value of